Welcome back to Explaining Everything, the channel where we dive into the stories and mysteries behind everyday things. Today's question comes from one of our curious viewers, Political Satire 6848. Thanks for the suggestion, Political Satire. You asked, what is the dry chemical powder used for firefighting? At first glance, this powder might look like the world's saddest baby formula, or the aftermath of someone losing a war with a bag of flour. But it's not food, it's not laundry detergent, and it's definitely not powdered sugar. It's one of the fastest, cheapest, and most effective ways to stop a fire in its tracks. Let's break down the fiery secrets of dry chemical powder right here on Explaining Everything. Let's start with the basics. Dry chemical powder, sometimes called DCP, if you want to sound fancy at firefighter parties, is a fine, powdery substance packed inside many fire extinguishers. When you see those red canisters on the wall, the ones you hope you'll never actually need, there's a good chance they're filled with this stuff. So, what is it made of? The most common recipe is monoammonium phosphate, if it's the ABC type, or sodium bicarbonate, if it's the BC type. Translation: either way, it's basically a special cousin of baking soda or fertilizer. You won't find it in your kitchen pantry unless you live dangerously, but chemically speaking, it's not far off. This powder is designed to put out three big categories of fires. Class A, ordinary stuff like paper or wood. Class B, flammable liquids. And Class C, electrical fires. That's why the ABC version is so popular. It's like the Swiss Army knife of firefighting powders, except instead of scissors and a tiny toothpick, it just smothers flames like a suffocating blanket. Here's the fun part. Imagine a fire as a rowdy party. You've got fuel, heat, and oxygen all dancing around like they own the place. To stop the party, you have to kick one of them out. That's where dry chemical powder crashes in, like an uninvited bouncer. When you spray it, the powder shoots out under pressure in a cloud so thick you can barely see your own bad life choices. The particles coat whatever's burning and instantly interrupt the fire's chemical chain reaction. Oxygen can't get to the fuel, heat can't keep the reaction going, and suddenly the party's over. The flames collapse faster than a campfire after a rainstorm. In the case of monoammonium phosphate, the powder doesn't just smother the fire. When heated, it actually melts slightly and creates a thin, sticky residue that clings to the burning surface, sealing it off even more. It's basically a fire's worst nightmare, a combination of suffocation and a clingy X that won't let go. And here's the kicker. It works almost instantly. That's why people love dry chemical extinguishers. You don't have to wait around for the fire to politely consider going out. You pull the pin, aim the nozzle, squeeze the handle, and the flames are done. Like microwave popcorn, but in reverse. If you've ever been in an office, a school, a gas station, or honestly any building that doesn't want to end up as a barbecue pit, you've probably walked past dry chemical extinguishers dozens of times. They're everywhere, quietly waiting for disaster. Why? Because they're cheap, versatile, and easy to use. You don't need a PhD in chemistry to figure them out. You just follow the PASS method. Pull, aim, squeeze, sweep. That's it. It's like playing a video game, except the stakes are much higher and you don't get extra lives. Firefighters also use big dry chemical systems in certain industrial settings, where they can flood entire areas with powder. Picture a snowstorm, but instead of snowflakes, it's powder choking the fire into submission. It's not pretty, but it's effective. Of course, the aftermath is messy. The powder gets everywhere. Floors, desks, your clothes, your lunch you left on the counter. It's the world's rudest confetti. But when the choice is annoying cleanup versus everything burns to the ground, powder wins every time. If you're wondering why we don't just use water for everything, it's because water and fire don't always mix. Try dumping water on an electrical fire, and you might become part of the problem. Throw water on burning oil, and congratulations, you've made a fireball. Dry chemical powder avoids all that. It doesn't conduct electricity, it knocks down flames fast, and it's portable. A person of any size can grab an extinguisher and use it. No fire hose training required. Plus, unlike some other methods, dry chemical doesn't rely on cooling the fire. It goes straight for the chemistry itself, cutting off the reaction like slamming a laptop shut during an awkward video call. Fire wants to keep going, but nope, the powder shuts it down. That's why, in a showdown between fire and powder, the powder almost always wins. Unless the fire is huge and out of control. In which case, yeah, call the professionals and get out of there. So to recap, it's the fine flame-stopping dust packed into countless extinguishers around the world. Usually monoammonium phosphate or sodium bicarbonate, it smothers flames, interrupts the fire's chemical reaction, and ends the chaos fast. It may not look glamorous. It may leave a mess that makes you question your life choices. But when a fire breaks out, that cloud of powder is the hero nobody expects. A dusty knight in not-so-shiny armor. Next time you walk past a fire extinguisher, give it a little nod of respect. Inside is a pile of chemistry just waiting to save your day. If you learned something new about this deep dive into these life-saving powders, don't forget to like, subscribe, and that's the story behind dry chemical powder, the unsung, slightly messy hero of firefighting. Also, if you have suggestions for our next video, feel free to share them in the comments below. We'll be sure to give you an acknowledgement for your contribution. If you enjoyed this video, please check out our other bingeable channels. Thank you for tuning in, and join us next time here in the channel that answers all the why, what, who, where, and how questions you've always wondered about, here on Explaining Everything.